Achieving dexterous bidirectional interaction in uncertain conditions for medical robotics evaluates our teleoperation architecture for medical tasks. We have selected 4 scenarios to evaluate its performance in the robustness of interaction, maneuverability, and providing haptic and visual feedback. The proposed architecture includes multiple control modalities for the teleoperator, provides virtual haptic feedback, can scale haptic feedback, and the replica can switch online between admittance and impedance behaviors. The first task was using a scalpel to cut a silicone soft tissue phantom using the haptic bimanual configuration of the controller. The system allows reliable control over the scalpel and is stable to the transition between media. However, the excessive unbalance between the physical inertia of the master and the replica does not allow taking full advantage of the haptic feedback. Additionally, using multiple cameras in inherently 3D tasks is not intuitive due to the need to continuously switch focus between the cameras. Nevertheless, the robot allows performing clean cuts in the phantom. The second task is about rehabilitation. It validated that the replica can be transparent on the patient's side, but, when the medical operator moves the master, the system can switch to the impedance behavior, allowing to assist and perturb the patient. The rehabilitation scenario validated that it is possible to switch between the transparent behavior of the admittance to an impedance behavior when the teleoperator needs to assist or challenge the user. This task also shows the same limitations in the visual feedback mentioned earlier, indicating that the multiple points of view approach is not recommendable for inherently 3D dynamic tasks. The ultrasound experiment allowed us to evaluate the accuracy of interaction with a soft material while trying to obtain a viable image. The system is highly maneuverable, and the line of sight is allowed to adequately control the 3D task when not in contact with the phantom. However, the user can rely solely on the visual feedback from the ultrasound screen when in contact, supporting the earlier observations that the stereo vision helps mainly in 3D tasks. The last scenario tested the shared autonomy by handling a potato chip for which a force sensor was mounted on the end effector for higher sensitivity. The experiment shows that the system can retain the admittance behavior, the interaction, while still being controllable via teleoperation through the impedance controller.